Hello and welcome to CS 206 Introduction to Discrete Structures 2. My name is Konstantinos Michmizos. I'm an assistant professor of computer science, and I'm really excited to be the instructor of four of the seven sections, namely 1, 2, 3, and 7 for this course. Please note that all of these sections are synchronous sections, which means that we will be meeting twice a week at a fixed time. Recordings of these lectures will become available shortly after the end of each lecture, but I would highly encourage everyone who really wants to do well in this course to make the best use of his or her time by attending the online lectures and by actively participating in the various ways we have available right now, starting from unmuting your mic to ask a question and going all the way to posting your own questions on our forum. Especially for CS Majors, 206 is an extremely important course as it is funneling into several other courses across the curriculum. But it is also taking place in a critical transition period, right in the middle of being a student and being ready to graduate. My aspiration is to use the material that we will be teaching in this course to change, ideally, all of you from just students to self-propelled scientists. And I consider this a challenging task, and I will need your help to accomplish this. You have to remember, though, throughout this course, that 206 will not only provide a platform to build mathematical skills, but it will also give you an environment to discover and build a rigorous scientific mentality. I want to start by giving you a disclaimer that we will go against the current school of thought for most of the students. And I'm going to push you to learn how to search for the practical value of applying your mathematical reasoning. To put it simply, the course will use some of the pre-acquired knowledge such as logic and mathematical reasoning to move you out of your comfort zone and learn something about combinatorics, probability, and graph theory. Teaching you about induction, for example, is easy. The hard part is to help you develop your own skills and expose them to an environment where you get to pick induction as your preferred solution based on the knowledge of what induction is and the hands-on experience of when you may use induction and when you cannot use induction. The course objectives are to develop logical thinking and a rigorous mathematical reasoning ability. You will learn how to think. You will learn how to push yourselves into thinking. And this will gradually result to a scientific maturity which will become extremely helpful in the years to come. We will not have a midterm or a final in this turbulent semester, but this does not mean that my expectations of your ability to learn and perform are going to be lower. I will walk you through the comprehension stage where you will discover the beauty of separating the problem from the method. You will experience a few eureka moments when you realize that quite different problems can be solved by following the same method. Or, for one problem, many different methods can lead us to the right solution. The students who typically complain that quizzes are hard are the ones who did not follow the trajectory that you see here, from understanding the facts to being able to understand how to use them and how to apply these facts in at least a few problems by themselves. This course is designed to give you what you need to move forward and a little bit more. We will run together and discuss some rapid tests that we will be having on a weekly basis. Every now and then, typically every month, a homework assignment will ensure that the methods that you've learned up to that point can now be synthesized, not just applied, so that you can be able soon to solve more complicated problems. I list here some characteristics of the level that you should be prior to taking this course and the level that I will want to leave you at in May. The main idea here is to be able to conceptualize problems and abstract them away to the point of bringing them to a level that you know what to do with them. You know how to solve them. The most helpful skill that I hope you will develop is how you can translate your understanding of the question into a solvable problem. And as you see here, there are many different steps going from understanding the question to solving the problem. We will go through each one of them. That is not always easy, of course, or something that is done automatically. So we will need all the help that we can get here from some textbooks that I list for your reference. Note that there is not a required textbook, and most of these books can actually be found online. There are three components that we will be touching during this course. The first one is our ability to count. This is not always easy, as sometimes we run out of figures, or we run out of ideas, or even years on how we could possibly count the possible outcomes of a process, such as the one related, for example, to the basis of our DNA sequence that you see here. The second component builds on our ability to count by introducing the notion of probabilities. Having a good grasp of how we can describe randomness through probabilities will allow us to see how we can use probabilities that are conditioned on other events. And we will see, for example, why random variables are neither random nor variables, but they're rather really excellent mechanisms that help us study how a process is expected to behave and how it can also deviate from our expectations. The last component is going to be a random walk into graph theory, which has a direct path to many real-world applications, such as our robots' ability to move from one place to another. We will also examine a particular type of graph, trees, and we will see the rather peculiar reason why computer scientists have that preference to represent a tree upside down. I cannot emphasize enough the importance of your participation in this class in order to do well, not as passive listeners, but as active doers. Essentially, you need to do three things in this course: solve problems, and solve problems. Trying to improvise during a quiz is a very bad idea. Rather, you should think of a quiz as the stage where you perform, and you perform what you have been rehearsing for some time now. And if you do that, I promise you that you will feel this sweet inclination to start solving problems by yourself, and perhaps one day actually be able to develop your own methods that will help others solve their own problems. That's it for now. I wish all of you to stay well, and I look forward to interacting with all of you in the months to come. We'll be in touch. Take care.